Hey guys, Professor Benson here. Hope you're doing well. Just wanted to show you how to do this particular spreadsheet exercise. This one, we're going to be doing three things surrounding confidence intervals and so on, but with proportions. And all a proportion is these are the type of surveys we hear in the political season where they say 53% of survey respondents favor candidate A. And then it'll give you some sort of margin of error, like plus or minus 3 points, and so on. And I just want to show you how to calculate that. And I hope that by doing so, it helps us illustrate some of the things in Chapter 7 and Chapter 8. So the easiest one to understand is this finite population correction, or this finite correction rule that they do. I've put the formula up here in this yellow text box. And the idea here is that all this is a precision bonus if the sample that we're taking is large relative to the population that we care about. This really only comes to play if you're either doing a really big survey or the population tends to be small, and I know all of them, like I'm surveying students at a school, or or people in my in some sort of professional organization. We want to sample the CPA Association for all the accountants that are part of it. If you're surveying, there's 150 million registered voters in the United States, or 130 million. I forget whether that's registered or registered voters or likely voters, but here we're going to be doing samples of something like 1,000 or 1,500, and so it's not even going to get it close. But what I want to do, we're going to go ahead and calculate just to see how this works. So I'm going to have you we'll put. I don't know. Let's put 30, 50, 100, 200, and we'll go down to about 1,000. And then at 1,000, we'll start doing 1,500 and 2,000. And we're going to go down to about 10,000, I think. So we'll go from here. I've got this, and we'll just keep going down. 9,500 to 10,000. Okay. And so we'll go ahead and make this that same gray. Oops. I think that's a slightly different color. There we go. Doesn't matter. Okay, so now what we need to do is we're just going to work through building this guy formula right here. So n as a percentage of n, and this is just because in this book, different statisticians will use 5% as the cutoff. Some will use 10% as the cutoff. This book uses 5%, so we just want to be able to see that. So we're just going to say, we're going to call this equal to, this is 30 divided by, and we're going to put it that whatever is in this cell, we'll do F4. Okay. Now we're going to do n minus n. So total population minus the survey size. So that's just going to equal 10,000 minus 30. And again, the 10,000. Now I could name this population guy. I'm not going to, because we're going to do a whole bunch of naming in this calculation tab here that we're going to be doing a little bit later. So we do C4. That is going to stay the same. And then, okay, so I've got 9,970. This is just equal to this minus 1. Again, F4. Okay, so now this is just going to be this guy divided by this guy. Okay, and then the population correction factor just tells me that this population correction factor just tells me it's just taking the square root of it. So I'm going to take the square root of this guy. So we're just going to do equals square root of that guy. Okay. Now, right now, let's just go ahead and move that comment over, because we're going to actually end up losing that comment when we paste this down. So right here we've got 0.9985. So is this guy square root? So I've got here, and then I'm just making sure that there's always pointing to the population n, that is an absolute reference. Okay. Boom. So we just double click on this guy. Okay. And then I'm going to go ahead and highlight at that right here that we're at 5%. Okay, so all this means is at about 5% is the point that is the point that the cutoff that the book uses, and this is just saying instead of using the regular standard error that I would otherwise normally calculate or otherwise normally get, we're actually going to multiply that standard error by 0.9757, and so we'll get, so it's going to reduce it by about 2.5%. And that just gives us a little bit extra precision. So if our regular, I'll go ahead and slide this guy out of the way. But so if our regular survey, if the regular standard error that we got were to be 40, okay, and now I would just say it's equal to 40 times 0.9747. So instead of using 40, I would use 39.99 or 38.99. So it's not a big boost there, but it's a little bit. As you get down, you know, if you're 50%, 60%, if you're getting a big number down there, then it does make a difference. Up here, you know, at 30 out of 10,000, you're at 99.9%. And so we don't make the correction for it. Now you could say, couldn't we always just multiply it? In fact, we could, and you might even just bake that into the software. It's just going to have a negligible effect until you get big. Okay, so then we'll just go ahead and take this guy and copy and paste up here. Okay, and I'm just going to make that H. Or sorry, in mine it's I have a shortcut as Control-Shift-H to highlight it, but really all you need to do is just go up here and pick a yellow or some color. I always end up using, it starts there, I always end up using that color, but and I don't care what color you actually use. But then all we could do is to say, if the question gives you, okay, well the population's 10,000 and the sample size is 50, so we'll just make sure that this is all pointing to the right spot. Then what is my finite correction factor, and should I use that? And I don't need to here. The book says 5%. This is 0.5%, and so we wouldn't end up using it. But let's say that my sample size were actually 1,000. Okay, and it's going to start throwing errors because these are larger than our sample size. But if I were to do now and say, hey, 75, that is greater than 5%. So I would want to use it, and then here is the finite correction factor. So I just wanted to get a sense of how fast does this finite correction factor start declining, so we can, you know, and it gives me a sense when I look at this square n minus n over n minus 1 and take the square root of the whole thing. That doesn't give me any sorts of intuitive sense of what is it doing and how does this change as n gets bigger. And whereas when I run it through a spreadsheet, so I always, like I just did this on my own, I always try and do these things because this is sort of my way of, you know, some people, as soon as they get a new electronic device, they take it apart to figure out how it works. That's what I try and do with these spreadsheet exercises, okay? But this is the easiest one, I think, for me to understand. Okay, so now we're going to go, I call it proportion, but in fact what we could call it is I want to do this normality distribution approximation, and then I want to find, we're going to end up using this p times 1 minus p, which is the proportion, a lot going forward. And so all I want to do, and I'm looking over here, is I want to say, okay, well let's do p as I'm going to put 0.01, and I've already formatted this as a percentage, and so then we'll do 0.02, 0.05, and then from here I'm just going to do 10%. So you could type 0.1. I've already put this in as a percentage, so you should be able to just keep going. All right, and so now we'll do this down to about 90, and then let's do 95%, 97.5%. 99 and 100, and that's just allow us to see how this moves. So 1 minus p is just going to equal obviously 1 minus this guy. Okay, then you just multiply them. Okay, and we're going to end up taking the square root just because over here we've got, you know, for the standard error or the margin of error, we're taking the square root of p times 1 minus p and in some cases we're going to put square root of n in the denominator. Okay, so now I'm just going to equal the square root of this guy. Okay, and what we're just going to notice is that this guy maxes out. I'm going to just go ahead and highlight that in yellow, and if that doesn't show up good enough, we can use a little bit of a brighter yellow. What this means, when we go to calculate the margin of error, or we go to calculate the required sample size, we're going to use this p times 1 minus p, or the square root of it. And what this is telling us is that we're going to need the margin of error is going to be the largest when the population is split 50-50. So this is often when you have, you're surveying voters about, are you voting, for the Democrat or the Republican or whatever the parties are in your country. And so so the margin of error, the level of precision is going to be the smallest, so the margin of error is going to be bigger the closer you are to 50-50, and so you're going to need a bigger bigger sample size. And we'll see this here. I'm going to go ahead and plot this